Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
Part against 3 because it's less than 2, which means it's anywhere less than 3, isn't it? That's how it internally works. The tree set internally uses the comparison method to compare the objects that we are adding into it against the objects that are already present in the collection.
Now, can you describe again? I really didn't get this part, the one you just explained, like 2, 3, 1.
When we have multiple elements that we want to add to a tree set, when I add the first one, it adds it. When I'm trying to add the second one, it compares the object that I'm trying to add against the objects that are already present in the collection and tries to put it, before it or after it. It fits the exact place depending on the sorting behavior. Do you understand that?
I still don't get it. Can you explain like that maybe differently? Are we comparing 2 with number 2, 3, and 1?
No. I add first object to the tree set, right? Yeah. When I'm trying to add the second object, the second object is compared with the first object.
Okay.
To see if it is less than the first one or greater than the second one, greater than the first one. So, if it is less than the first one, the second object is kept first. Because we want to maintain the sorting behavior, right?
Yeah.
So, if I give you a number, how do you sort them? We take each number, we try to compare with the other. If it is less than it, we want to put first. If it is greater than the other, we want to put, next to it, right? Same way the research works internally. But to do the comparison, it uses the CompareTo method. Shalina, are you clear?
Yes, Neha, thanks.
Neha, internally, how it will place these elements? Is it in a tree structure and then compares the elements, or?
See, if you go and see it, the collections internally maintains arrays. When we see some kind of a specific collection code, right, they internally uses arrays to store these elements. But the logic on, how it, this is the code. I don't know. I don't have the Java code. Maybe, or from the site or using any decouplers, you can get the code and you can go through it. So it has like maintained in the form of an array, and it does swap the elements and everything as part of the order that it maintains. See, actually, folks, when we say treeset.add, this is also a method. And, what is exactly doing to be present in this method. Right, Venkat?
Yeah.
So, all these collection classes have the array as a base thing to use. Yes, you're asking something?
No.
Venkat, do you understand the concept, like, the tree set, sorting behavior, and where we implementing the comparable interface and everything? I mean, everyone, not only Venkat.
Neha, I have a basic question on this. When you say that the collections, it is a root interface for the rest, like set, list, and all that. Usually, when it is an interface, it has to be implemented by the child or the extended class, right?
Yes.
So when we use this set is an interface.
Set is an interface, yes.
Right.
Set is an interface.
Yeah. So when we are using set here,
we are not creating objects of a set. We are creating objects of a tree set. We cannot create objects of any interface. Tree set is the implementation class of a set. It's a class. It's a concrete class.
Implementation class.
Yes.
Okay.
Tree set implements sorted set, which is an interface.
Right.
If you have gone through the slides that we have discussed in the previous class, you could have seen that there is a sorted set interface, right?
Right.
The tree set implements the sorted set interface.
Okay.
It's a concrete implementation class of set interface.
Okay. So it's implementing that. Okay.
Folks, this is about set and the implementation classes of a set. I want you to practice has set, linked has set, as well as a tree set with strings, with user-defined objects like student or employee, car, any user-defined object, and try to work on that. And the next set is from the list. List is an interface which is extended from the collection. So the unique property of the list is it provides positional access. It is indexed. What do we mean by this? We say positional access, or we say, indexed. What do we exactly mean by that? See, when I add an element to the list, the order is maintained, and the positional access means I can say directly go and say, get me the 5th element, get me the 10th element, or get me the nth element. I don't necessarily start from the first, go to 2nd, 3rd, I don't need to travel sequentially. I can go and get the 10th element or any nth element which I want to get from all the list implemented classes. List is an interface, and we have linked list and ArrayList that are implemented from the list interface. ArrayList allows random access, so for faster iteration, we use ArrayList. So in a linked list, it's like a node wherein we have a link to the previous element and a link to the next element. When we have more insertions and deletions, we go with the linked list, and when we need faster iteration, we go with the ArrayList. And folks, like all the collection classes, like we talk for the set, we get iterator object. The same way we can get the iterator object on the list implemented classes also. So how do we create object of an ArrayList? Using the new keyword, right? As we have already seen, if you're not using generics, right? I'm not using generics here. So when I just create an ArrayList, I can add any kind of objects to this ArrayList. I have added string, and I have added student object also, right? When I don't, same with all the collection classes, when we don't use generics, we can put any object into the collection. But when we use generics, we are restricting it to a specific class, which we have already seen, that is applicable across collections, sets, lists, maps, and everything. So when I declare an ArrayList of strings, I cannot add student objects to it. So folks, we have already seen different ways of iteration. What are the ways that I've seen? We have seen the set iteration using the advanced for loop, and we have seen the set iteration using the iterator. So you can iterate through the list the same way. Let's say I'm getting an iterator object on it. So the same way you can iterate through list also. So this is one way of iterating through a list using the iterator. And this is the advanced for loop. This is the second way of iterating through the list. So we said the list provides positional access, right? When we have the positional access, I can get the first one. I can get the second one. So there is a method get, which is used to get the elements from the list. Folks, even lists are zero index. We say, string characters are zero index. Arrays are zero indexed, right? The same way, lists are also zero indexed, and when I have two elements, it's 0 and 1. So I start from 0 and I go till size minus 1. We have studied that there is a method size which returns as the number of elements in the collection. So I can say a list dot get of 5, list dot get of 0, get of 1. So these are three different ways that we can iterate through a list. So we have created an object of the array list. We have added string elements to the list, and we have seen three different ways of iteration. One is through using the iterator, and the second way is using the advanced for loop, and the third way is using the positional access that the list supports. Folks, any doubts on this?
Neha, I'm back. I am having really difficulty understanding this interface levels. Java.util.collection is the root interface, right? For all these,
yes.
I understood everything what you said, but I have this basic conceptual question, so these are the main interface. Yeah, list is the sub interface, or the interface of collection, right?
List is an interface which extends the collection interface.
Yes.
In Java, class extends another class.
Right.
Same way, an interface extends another interface.
Right. So now, when we actually work with interface, we implement the methods and we use, if at all there are any.
We don't implement these interfaces. We have the collection classes that have already implemented the interfaces. Those are the classes that we are discussing right now. List is an interface, and
yes.
ArrayList is a class which has implemented the list interface.
Okay. ArrayList has already implemented. Okay, is a class.
ArrayList is a class which has implemented the list interface and have provided behavior for all the methods in the list.
Okay, got it. Thank you. I have been always struggling with this. Okay, now I got it. Thank you.
No problem. Folks, any doubts in the list, different ways of iterating through the list?
Neha, I have a doubt on the previous one, CompareTo.
Yes. What's the doubt?
Could you go down that CompareTo where you have given? So this CompareTo you use most of the time when you have user-defined collections, not collection, I mean user-defined arrays.
When you want user-defined objects to put in a tree set, right?
Mm-hmm.
Or if you want to put it in a tree map, because these two collection classes provides the sorting behavior. So if you want to put them, any user-defined class, user-defined class objects into this collection, that specific class has to implement the comparable interface and has to provide the behavior for the CompareTo method.
So only in tree set and tree map, right?
Yes.
Okay. And so same functionality, can you able to use when you use equal and hash code method?
No. Equal says it's equal or not. That's all. It doesn't say which is greater than the other or one object is less than the other. It doesn't say that, right? Equals is used to check if they are equal or not, right?
Okay. And then what is this CompareTo? CompareTo isn't it do the same thing?
CompareTo method is providing a behavior on what basis it has to compare two different objects. When you want to sort, you want to know the comparison between them, right?
Mm-hmm.
When you want to sort any object, you have to know the comparison on, the basis of comparison between the objects, right?
Okay.
That's what we are providing in the CompareTo method.
Okay. Okay, I think I got it now. Okay, thank you.
That's how we interact.
So the logic in CompareTo can be different based on our business requirement,
exactly.
Right?
If you want to sort it based on a name, right? You provide a different comparison. Instead of saying comparing roll numbers, you compare names. Instead of comparing names, you can compare the section, or for that matter, anything. Just your own business specific behavior of the comparison that you want to specify among objects or between objects. So folks, we have the remove method to remove the elements from the collection, right? So, let's run this and see. So we're doing it using iterators and using the advanced for loop, and folks using the positional access. So folks, you see the order in which we added elements, we have the same way. List is ordered, but list doesn't provide sorting. ArrayList or linked list, they doesn't provide sorting, but they are ordered. So here in the last way of the iteration, or I'm accessing it using the position. I'm saying get off 0, right? And I'm saying get off 1 and get off 2. So it's using these elements. So folks, in the same way, try the linked list. Okay? Try to create object of a linked list, add elements to it, that you can try student objects or any user-defined object so that you understand things better. So those are the implementation classes for the list interface. And folks, we have a class called as vector. It is a list implementation, but it is deprecated. We don't use it. If you're coding now, we don't use vector because vector is similar to ArrayList. The difference between them is vector has synchronized methods, because of which the performance is slow. The vector's performance is slow because of the synchronized methods. Other than that, vector and ArrayList are the same, but the vector has synchronized methods because of which the performance is slow. And if you're coding now, we're not going to use vector. Instead, we use ArrayList. That's about the list implementation class. And folks, we have the map interface, right? We have seen the map interface. It's all apart from the collection interface. If you see the hierarchy, map is a separate interface. It has nothing to do with the collection interface. The map interface maps unique keys to values. A key is an object that is used to retrieve the value at a later point. So when we put something into a map, it is a pair. It is not a single object what we put into a map. It is a key and value associated with it. You can store the value in the map object. So after putting the values in the map object, those values can be retrieved using the key. So we have different methods in map. The clear method is to remove all the elements in the map, all key value pairs. What we put in a map, it's a key value pair. It's not a single element that we put in a map, we put a pair. It's a key value pair. And if a specific key is already contained in the map, we use the contains key method to check it. And if we want to check if a value is already present in the map, we use the contains value. We have two methods, contains key and contains value, to check if the key is present and if a value is present. And folks, map doesn't have an iterator. We say list.iterator. Folks, listen very carefully. And set.iterator. But we don't say map.writeTrader. We cannot say that. Instead, we have an entry set method which returns the set. It returns a set, and folks, in the previous classes, we were discussing about the inner class. In map, we have entry as an inner class, and entry has a key and a value. So it returns a set which contains the entry object. An entry object contains both key and a value. And we have the get method to get the value based on the key. What we pass to the get method is the key, and this method returns the value that is associated with the specific key. And we have the isEmpty method, which returns true, or it checks if if a map is empty or not. And we have the key set. It returns a set which contains the keys of the map. Keyset method returns a set, and it contains all the keys in the map. And we have the values, which
Neha, map contains null keys.
It depends on the map interface implementation. Different implementation classes have different ways. If you take the hash table, it doesn't allow null keys at all. If you take the hash map, it allows a single null key. And whatever single null keys cannot be duplicated, right?
Okay.
Even in, keys doesn't make sense to be duplicated, isn't it?
Yes.
So we have the key set to get the keys, all the keys of the map. And the put method is used to add, a entry to the map. See, we have already said that, in map, what we put is a key and a value. So map, when you're putting something in a map, it's two objects. One is the key and the other is the value. So if you want to add, all the elements in a specific map to another map, we use put all. And to remove a specific entry from the map, we use the remove method, and we have the size method to get the number of key value pairs that are present in the map. And we have the values method. It returns a collection that contains values. If you see, we have the key set to get only keys, and we have the values to get only values. And if you want both, we have the entry set method. And we have the hash map and the linked hash map. We have one more thing called as a hash table. Hash table, just like vector, is deprecated. We have discussed like vector and ArrayList are similar, but vector has synchronized methods because of which performance is slow. Same way, we have hash map and hash table. Hash table has synchronized methods because of which performance is slow. And the hash map, it uses a hash table to implement the map interface, and it has the operations like get, put, to access the method. Whatever the methods we have seen, both the hash map and linked hash map has it. And if you see the linked hash map, it expands hash map and maintains a linked list of entries in the map. Basically, it maintains the order in which we added elements. When we add elements to a hash map, the order is not maintained. But when we add elements to a linked hash map, the order in which we insert is maintained in the linked hash map. All the lists maintain order. And in set, the linked hash set maintains order. And in map, the linked hash map maintains order. These are the different methods that, that we have as part of the map interface. Folks, any doubts before we go ahead and, get our hands dirty with map implementation classes?
Neha, could you show an example for the map.entry?
Yes, we're going to see the code.
Okay, that's great. Thank you.
Okay, maybe you'll be more clear when we see some code. Folks, any collection class, I think I'm reiterating it multiple times, but we just create object using the new keyword. There is nothing rocket science for collection classes. Any class has to be instantiated using the new keyword. So it's the ArrayList, HashSet, HashMap, doesn't matter. We use the new keyword to create objects of it. And folks, please pay attention to the syntax, right? In a map, we store or we put a key value pair. So one is the key and the other is the value. So when we're declaring a map, when we're using generics, we have to say on what are the objects that we're going to put for a key and what are the objects that we're going to put for a value. We said that the key is going to be string object and the value is going to be student object. And when we try to put elements into a hash map, we are storing a key and a value. The key is the name of the student and the value is the entire student object. So at a later point of time, if I give the name, it's going to, I'll be able to get the entire student object from the map. So we have added 3 elements. Folks, observe in collection, we have an add method, and in maps, like the collection is basically in list and set, we have an add method to add elements. And in map, to put a key value pair,
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.